Welcome back, ladies and gentlemen, to an exciting video. Now, I know we're doing this a little bit out of sequence, but it is one day before fall break, so I think it's a really good time to be able to just get this done, get this taken care of, and knock out the nomenclature piece that is associated with Chemistry 2. Now, again, you've had all of this before. This should be a pretty quick review, but I want to make sure we're all on the same page because it is imperative that you are able to write out the chemical formula when given a written name and vice versa for all ionic, covalent compounds, and acids. So let's go ahead and dive on in. But before we do that, we need to make sure we know a couple vocabulary terms, and we're going to be talking about binary compounds, ionic and covalent bonding, type 1, 2, and 3 ions, polyatomic ions, and acid nomenclature. So please remember that nomenclature is the system for naming compounds. We have to have a system to ensure that all people know the names of compounds. We want a system that is across the board, easy to use, something that everybody's going to know, and something that everybody is going to understand. So it's also going to be important for you to be able to take the name to formula and vice versa. Again, just the same type of stuff that we've done in Chem 1. Now, it's also important to know what types of atoms form what types of compounds to be able to do the nomenclature rules correctly. We could break them down into type 1, type 2, and type 3. Type 1 is a metal and a non-metal, typically the first two columns on the periodic table plus aluminum, and including silver and zinc. Type 2 are your transition metals, excluding silver and zinc, but including tin and lead, plus a non-metal, and your type 3 are just all non-metals. So different nomenclature rules apply based on what type of elements are in that compound. So let's talk about type 1. Type 1, keep in mind the metal always precedes the non-metal, so NaCl, not ClNa. Metals of groups of 1, 2, and aluminum are a part of this. So make sure you're able to understand which elements are involved in which type of nomenclature. It's the same first name of the element. Sodium is sodium, calcium is calcium, potassium, aluminum, etc. For the second element, remove the last syllable and add "ide." So instead of fluorine, it is fluoride. Instead of phosphorus, it's phosphide. Instead of oxygen, it's oxide, etc. Okay, pretty straightforward there. Now, to go from the name to the formula, remember we need to determine the charges. Remember your plus 1, plus 2, plus 3, plus or minus 4, minus 3, minus 2, minus 1, 0. You need to utilize those and find the way to balance so that the net charge is equal to 0. So, for example, sodium and bromine. Sodium is a positive charge, bromine is a negative. Well, the plus and negative cancel out. We get NaBr. Aluminum is a plus 3, oxygen is a minus 2. In order to get those to balance, the least common multiple of those is 6. So we need 2 aluminums and 3 oxygens to get a plus 6 and a minus 6. Lithium nitride. Lithium is a plus and is a 3 minus. We need 3 pluses to cancel out the 3 minus. So we have Li3N. Calcium is Ca. Sulfide is S. I look at the charges on the periodic table. Calcium is a 2 plus. S is a 2 minus. They automatically cancel out. So our formula, CaS. Strontium phosphide. Strontium is Sr. Positive charge. Phosphide, P, 3 minus. We need 3 strontiums to cancel out the negative 3 on phosphorus, so this is Sr3P. We're going to name this compound. Al is aluminum, and O is oxygen, but we're going to shorten that. We're going to add that suffix oxide. Okay, again, pretty straightforward stuff. You guys should be in pretty good shape. Let's move on. Now, type 2 ionic compounds are compounds with ions in transition metals. We are not including zinc and silver, but we do include tin and lead in this. And those ions can have multiple oxidation states and charges, so it's really important that we include a Roman numeral. That Roman numeral indicates the charge and is included in the compound name. So Fe, when it's plus 2, is iron 2 oxide. When it's plus 3, it's iron 3 oxide. So you get the idea here. Remember that the Roman numeral is indicative of the charge or oxidation state that is present in the compound. So here we have cadmium, and there's a Roman numeral 3 that tells you that cadmium has a 3 plus charge. Bromide, again Br, the minus. Make sure your charges are balanced here. So this is going to be Cd, Br3. Iron 2 nitride, again, iron here, has a 2 plus. Nitride, 3 minus. Least common multiple of 2 and 3 is 6, so we're going to need 3 irons and 2 nitrides. Okay. Now we look at the bottom two here. These are in your type 2, so we know that this is cobalt chloride. And we know this one right here is nickel oxide. But what are the charges on this? Well, we don't know the charges in the cations, but we can determine it from the charges in the anions. We know that Cl is a -1, and there are 2 of them. So the total negative charge on this is -2. If we know that everything has to cancel out to be 0, that means that cobalt has to be a 2 plus. So in Roman numerals, we're going to put 2. And same thing here with nickel. Oxygen, -2. So nickel must be a +2. Okay? Pretty straightforward on how to do that as well. Now, some cations and anions are what are known as polyatomic, meaning that they have more than one atom associated with them. Now, they act just like any other ion with a charge. They just have more than one atom that's associated with them. Remember, when you have multiple polyatomics, you have to put them in parentheses. Okay? Otherwise, the subscripts look funky. So keep that in mind as well. You have a polyatomic chart on the right that will be really helpful for you to use as you go through and complete these types of problems. Again, a couple more practice problems just to help us out. We've got sodium here. Sodium is Na. Positive charge. Nitrate, I look at my chart here, I find nitrate. Okay, that is NO3. It's a minus as well, so this is going to be NaNO3. Easy stuff. Aluminum sulfate, aluminum is Al. Again, all this is on the periodic table. Sulfate, SO4, that's a 2 minus. So again, we need to look at these. We need to get those to 6, so this is going to be Al2, and in parentheses, SO4, 3. 3 of those makes up -6. PbSO42, so this is a little bit different. We're naming this. Same procedure though. Got lead, sulfate. Need to determine the charge on Pb here. SO4 is a 2 minus. There's 2 of them, so that's -4. So Pb has to be a +4. So in Roman numerals, that is IV. Same thing here. We have magnesium. Nitrite. The next ones we're going to look at are type 3, which are covalent. Remember, these are all nonmetals, so you're not going to find a single metal in this. Everything to the right of the stair step will be in these compounds. In this instance, we use prefixes to determine the number of atoms of the element, so you don't cross any charges. There's no charges involved at all. We just look at the number of atoms, and that determines the prefix we put in front. CO2 is carbon dioxide. CCl4, carbon tetrachloride. N2O, dinitrogen monoxide. So type 3 covalent, we're looking here. Carbon, C, mono means 1, so CO, so our formula is CO. Tetraphosphorus decaoxide, phosphorus P, tetra is 4, decaoxide O, 10. Straightforward. Again, no problems here. So the last bit of nomenclature that we are going to talk about today is acid nomenclature. Now, acids are unique compounds that dissociate to create H+ ions. So if you're looking at an acid, it typically has a hydrogen at its very beginning. Things like HCl, HBr, H2SO4, etc. To determine the naming rules, we look at the anion of each acid. If it ends in "ide," we put hydro in front of the root of the ion, add "ic" at the end, and acid. So bromine, hydrobromic acid. Okay, so if it's something bromide, hydrobromic acid. If it ends in "ite," then it becomes OUS acid. So nitrous acid is a good example. If it ends in "ate," ends in "ic," acid. So if it ends in "ate," like it has a sulfate ion, H2SO4, sulfuric acid. Last bit of practice here, we're going to Last bit of practice here focused on acid nomenclature. Again, what we do is we take a look at the anion here. We know this is an acid because it starts with an H. The anion is sulfate. Okay, ends in "ate. So this is sulfuric acid. Okay? HI, this is an iodide. Ends in "ide. So this is hydro iodic acid. Last one, NO2. This is nitrite. So this is going to be nitrous acid. Simple enough. Follow the rules, should have no problems. So hopefully you reached the learning objectives for this video. I'm not going to talk too much because I've talked enough already. Have a great day, guys. We'll talk to you later. Bye-bye.